All right, folks, let's do this one. A firefighter, distance d, from the building directs a stream of water from a fire hose at the angle above the horizontal as shown in this figure. If the initial speed of the stream is a v naught or v initial or whatever what you guys like to use, what height does the water strike the ground? So, all right, so let's set this up. So this is just going to be a standard kinematic equation that we've been doing this over and over again. I hope you guys are used to this. And remember, even though you probably have or have not learned this, it doesn't really matter because common sense states that you just magically know what a parametric equation is, which is basically this. This is going to be a point, L, and I'm going to call that point X and Y. And this point is going to vary. This is going to be the actual, and the building, I guess, will be at this spot, so it's not going to go all the way that far, but you get the idea. So maybe it's like right there, and there's a window, and it's going to strike somewhere. I don't know. It's not really a good drawing, but whatever. Who cares? So this is going to be X and Y. X here is going to be V naught cosine of theta times the time. So that's going to be the position of X depending on these two variables, pretend that these are constant, and depending on the time. So Y is going to be a variable. That's going to be V naught. So it's just a matter of, not just setting up your math, folks, but reading your math. So minus gt squared over 2. And really, that's it, folks. That's all the equation you're probably going to need. So the variables that it's given is a firefighter at a distance x from the thing. So in this case, x would be d. And the angle is going to be the angle theta. So I'm just going to call that theta. And above the horizontal shown low, if the initial speed of the V is V naught, at what height does the water strike the building? Wait, what is it asking? If the initial, so if you're actually given the initial speed, which is going to be V naught, I guess, at what height does the water strike? So you're just going to call y equals h in this case, and x be d, which I already did that. And so I guess all you're going to be doing is solving for t here, which I'll do that right here, is going to be x v naught cosine of theta. I know these videos kind of suck, folks, so forgive me for that. So y is going to be h, is going to be v naught sine of theta. X, I really don't know how to cover these topics. As you can tell, I'm struggling here. God damn it. So minus g over 2, I'm just a weird fuck. G square over v naught square cos square theta. There you go, folks. Okay. Okay, so I guess it's really just going to be the equation here. H is going to be tangent of theta times x, or in this case d, minus g over 2 v naught square x square, and I like to put secant squared theta. And I guess that's the answer. I mean, let me just change. So if this is d and this is d squared, then wait, what did I do? All right, guys. So I guess I didn't see answer. Let me move this. So this is going to be the graph. There's your v naught. So you're given the angle, you're given d, you're given d, you're given v naught, you're given that angle. So you can just plug it on there. You get your height that it takes for it to strike the building. If the initial speed of this, at what height does the water strike the building? Okay, well, I guess we're done. So I guess the height is really just going to be tangent of theta times d minus g d square. I don't know what I'm doing anymore. D over 2 v naught square secant square theta. All right, we're done.